Hello students, welcome to Revisedu learning platform. Today in this video lecture, we are going to cover two topics from chapter number 1, that is electric charges and field from class 12, that is electric field and the electric field intensity. So today we are going to study about what this electric field is. So first of all, let us know by the definition that what electric field means. So as the name suggests, that this field is developed due to the electrical nature of the particles. So let us see that what it states. So electric field is actually, it is the space around the body. Now what type of space we are talking about? So the space around the charged body up to which it can apply electric force on other charges is known as electric field. Right? So the electric field is actually what it is, the space around a charge. For example, let's take that this is some charge. So the space around this charge. What is the space around the charge? You can see that entire space over here around the charge is the place up to which it can exert its properties, right? It can apply some electric force on other charges. For example, there is one other charge over here. So due to the presence of this charge, what's going to happen is there is some electric force which is going to develop, and due to this, if it is at this distance maybe, it cannot. But if it comes a bit nearer to its area, what will happen? Some electric force will be experienced by the second charge which is near to the body, right? This charge will exert some electric force on the other charge. So what is happening is that the electric field is getting developed, right? It is applying some electric force on the other charge. So this is known as what? It is known as electric field. So over here, to know the concept of electric field, we should know about something which is very important, that is that the charge which produces electric field is known as source charge. So always remember there is something known as source charge that is represented by Q, right? And there is something which is known as test charge. Test charge is the one where the electric field is actually felt. Means this is the one which is producing that electric field, right? It is producing that electric field. Whereas Q0, which is known as a test charge, right? What is happening to this test charge? This test charge is actually experiencing the electric field due to the source charge. So these are the two terminologies that you should know about an electric field. But now we have seen what is electric field, but what is the strength up to which this electric field can be experienced by any particle? So in order to calculate that strength of the electric field, what we do is we have something which is known as electric field intensity. So electric field intensity is simply what at any given point in an electric field, it is defined as the force per unit test charge at that particular point. Means that electric field, the electric field intensity at any point is equal to what? It is equal to limit Q0 tending to 0 F bar by F vector by Q0. This is your formula for electric field intensity. This gives you actually what the strength of your electric field. Fine. So over here, what we can see is the F is the force which is experienced by the Q0 test charge at any point which is at R distance away, right? So here we can see this thing, and also it's the strength of the electric field at any point which this formula is representing to you. So Q0 tending to 0 actually represents what? Q0 tending to 0 shows that the magnitude of test charge, the magnitude of test charge can never be equal to 0. So students, I request you all to just find out the answer that why this test charge cannot be equal to 0. Why we say that the magnitude of this test charge is always greater than 0. Once I have told you that there is certain minimum charge that the body has in it, right? Let me just tell you a hint. So let me give you a hint. Your hint is that we have read about a property of charge which is known as quantization of charge, right? So this is your hint. Now please let me know in the comment section below that what you feel and what you guess about why this test charge cannot have a magnitude which is equal to 0. Why is it Q naught always greater than 0? Fine. Alright, moving forward we have that how we can calculate the direction of your electric field intensity, that in which direction is the field actually experienced, right? So before knowing that, first let's know the unit of these electric field intensity. So the unit is represented by Newton per Coulomb. This is your unit of electric field intensity, right? Now let us see. What we assume is that the direction of electric field is always from positive source charge to a negative source charge, right? So your electric field, as you can see in this diagram, always travels from positive to negative. This is the sign convention that we use for our convenience. So based on this, what we can say is that if the test charge placed in the electric field is positive, then the electric field is going to act outwards, means away from the positive charge. While if the electric field acting on the point which is negative test charge, then the electric field is going to act inwards of the negative charge, means it is going to be towards the negative charge. So this is the concept behind actually what electric field intensity is. So the points to remember, or in order to summarize the entire topic, I can say that electric field is actually the space around the body up to which one charge can put some effect of its electric force on the other charge, right? So it is actually the area around the body till which the electric charge can be experienced due to charge 1 on charge 2, right? And we have read about a very important thing, which was that the source charge in the case which actually produces the electric field, due to which the electric field is getting produced, is what it is known as your source charge, that is Q, right? And there is something known as a test charge, which is actually that charge on which we have to see the effect of this electric field or force, which is denoted by Q naught. And we have seen that this Q naught is never equal to 0. The magnitude of this Q naught is always greater than 0, right? So why is there something which is known as that this test charge, the magnitude of this test charge is very small? It cannot be distributed the electric field produced by some source charge. It cannot distribute that. But how is actually it not equal to 0? This is the thing that I have asked you. So remember to answer in the comment section. And we have also seen in this topic that electric field intensity is given by the formula over here, right? Where F is actually the force. So this force is a vector quantity which is experienced by Q naught at any point which is r distance away. What we are actually talking about when we say that r distance away, let's suppose that this is Q, your source charge, while this is Q naught, your test charge. So they are separated by, let's say, some distance r. So we can say that the electric field due to Q, the source charge on Q naught, is given by this formula. While we can also say that this electric field is actually is proportional to inverse of your distance square, right? Now how this is happening, we are going to see it in the next class, that why is it exactly proportional to r square. If you want me to make a video on how actually this thing is happening, on how actually we can say that E is equal to 1 by r square, then let me know in the comment section below. Thank you.